guys, welcome back to Home Built, and this week we are back on the Frankenhauler and hopefully get something done about this rusty roof. Alright guys, welcome back, and if you're watching last week you will have seen that I was tackling the rust on the Frankenhauler, and this week, yeah, nothing much has changed. There's still a lot of rust in this old cab that I need to tackle before we can move forward on the body swap onto the coaster bus and all the rest of it. If you missed it, I'll put a link up above so you can catch up, and like always, please like and comment. All that sort of stuff really helps out the mysterious algorithms. So just a quick update on the Alpha. Normally I've been trying to alternate weeks on the videos, but I think I have found a solution for the steering. I've found a quick rack for it's actually for a Toyota A86 that I think is very similar to what's in there, so it should mount up very easily and swap easily with a better ratio and all the rest of it. So that is going to take probably a couple of weeks to get here at least, and then the steering arm. So there's things to do on that, but really it's got to sit and wait for parts. So thankfully I have plenty to keep me busy on the Frankenhauler. And while we're talking about the Frankenhauler, I made some discoveries in the last week, so I thought I'd just take you over them. So let's go back over to the chassis. So this is the original chassis here of the Frankenhauler, as you guys saw when I pulled it apart, and we made some discoveries. I've been selling some bits and pieces off, and I had a guy come to actually get the steering box out of this truck. And we noticed a few things. So for starters, whoever did the steering box swap, the steering box went in here, and they obviously didn't want to remove the engine, so they just, looks like they probably took an oxy and took a massive chunk out of the frame, which would have weakened it a whole heap, and then just bolted a piece of angle iron over the top and called it good, which, yeah, that's, I suppose it did hold up, but yeah, that is definitely not a good swap. And that brought me to the engine mounts, and we noticed these are definitely not factory engine mounts, some cobbled together bits of angle iron. So we did a little bit of research, because we thought, I thought originally that this was the original Y-block engine, because these did come with a Y-block, but it appears by the engine number that we looked up, I believe this is a 251 or 256, something like that, cubic inch engine out of a Mercury. So yeah, it's a little bit cobbled together, but it obviously worked for a time. But in any case, I still have a few bits I need to salvage. So before I sort of go too far and leave this too long, I thought I'll cut out the body mounts, the body frame mounts I have to remove, and I always have to remove these running boards, which are actually in really good shape. So let's get them off, and also the fuel tank. I don't think I'm going to use it, but let's get it off anyway. So these old rivets were actually really hard to get out, and I couldn't seem to knock them out with a hammer. So I just had to cut them and grind them off, and tried using a hammer, and the best bet was a bigger hammer. All right, so I've got the bits off of the chassis that I need, so now it is back onto the cab, and let me bring you in here and show you what I've got to tackle first off before I get back onto the inside. All right, and you can see here, you can see the holes going through the cab there that I need to weld up, which I'll probably try and tackle that just from the inside and just try and weld it up without cutting in and welding in a section. But this bit here looks like it's going to require another folded piece that I'll cut out and shrink, stretch, and make a patch that fits. All right, because I'm going to weld from the inside, I'm going to use this little piece of brass rod that I've had for ages, which I always use as a heat sink. Because my magnetic tool that I showed you guys last week won't sort of fit into this place as well, whereas this will, I can put it up in here and clamp it into place. Now, while I was thinking of it, this clamp is actually something I discovered a little while ago, and it may look like a lot of your regular clamps, and this is not sponsored, by the way. I just discovered these things and thought it was amazing, but basically it will without adjusting the end of it like a regular vice grip, you can just clamp it onto any thickness with just one clamp. So if I've got this chunk of wood, one lot, and it works. I'll put a link in the description for those who like it. I discovered these things. I thought, wow, this is amazing. So much quicker and easier than messing around and adjusting your little clamp. It'll just adjust itself to the thickness you need. So I use the MIG on the back, and you can see it just welded through nicely without creating a lot of mess on the front. So I'm just going to tidy that up with a grinder. And next bit I'm going to tackle is this, which is going to be a little bit more difficult, but I think it's doable. So with this, I patch in a similar fashion to the way I have in the previous episodes. Just cut out a patch, fold it, a bit of work on the shrinker stretcher, and make it fit. All right, let me quickly talk about now the difference between MIG welding and TIG welding in the patches, because many of you have noticed that I TIG weld most of my work these days. I don't use the MIG as much. Now, let me cover the two different types. So this is the MIG gun. MIG welding is the easiest type of welding to start with, to learn. Fantastic. They're relatively affordable now, and basically you have a spool of wire inside the machine so that when you pull the trigger, the wire comes out, creates the arc, and lets the gas out at the same time. So it's just basically like a hot glue gun. You just stick it in there, press the button, and once you've got the settings right, you just go. And it's a very, very useful tool. Now these days, like I said, most of the time I'm using the TIG. So as you see, you've got the TIG torch with a tungsten electrode. The gas comes out. I use a foot pedal. You can adjust the amount of amps that you're delivering. So you set it at the max, and if you've got your foot all the way down, you get the max, just like an accelerator. But sometimes when you learn and you get better, you can see that, okay, I'm a little bit too hot, so you can just let off the pedal a little bit and feather in the power. And of course, then you need some filler rod, and any material you're adding, you're just adding the filler rod. Whereas with the MIG, it's automatically adding the wire to your job. What are the differences, and why do I choose to use the TIG over the MIG? The MIG's benefit is that it generally can add less heat into the job because you just sort of zip. It's just a very quick, short zap into the job. The issue I find with the MIG is that it adds a lot of material all at once because you have no choice. Whereas with the TIG, you can add no material at all. If you've got the edges really close together, you can just fusion weld them and basically melt both sides together without adding any extra material, which means there's no grinding down, or much less grinding down at the end. With the MIG, you're adding material, and I often find you've got a very big, thick line around that you need to grind out. And because the wire has to go through the gun, it's quite a hardened steel that goes through, and it ends up, it creates a very, very hard, brittle weld, and requires a lot of grinding to get the patch out. And I often found with the MIG is that even if you take your time, you can put the repair in doing minimal amount of warping, but the flip side is that grinding it off ends up adding so much extra heat to the panel that it warps it anyway. Now, the benefit of the TIG, and why most of the really high-end restoration shops use a TIG, it's slower, but it's very delicate. There's no spatter, which is quite nice, so you're not getting holes all through your shirts and jumpers, etc. But you just add as much filler as you need. So it's got a much smaller bead around the edge. There's less grinding, and it's a much softer weld. So even when you do a tack with a TIG, you can hammer out that tack and you can actually see it deform. Whereas if you try and hammer out a MIG tack, you probably notice you barely dent it. Whereas the TIG is much softer, and it gives a much more malleable repair, which seems to me at least, be much closer to what the raw steel on the car is like anyway. And yeah, I much prefer that. And I said, if you watch any of the really high-end restorations, generally those guys are using the TIG, and I much prefer it. But you can definitely do the job with the MIG. I did the 911 completely with the MIG, 100%. Some of the Alpha with the MIG, some with the TIG. I learnt TIG on the Alpha. Now, you see here, I did a couple of things with the MIG, but generally the TIG is the way I like to do it. So hopefully that clears it up. And speaking of welding, last month, Weldclass did a giveaway of one of the ProMax 680 helmets. And congratulations to Jamie Caspers, who won the helmet. And this month, Weldclass are going again. And we've actually got this welder, and actually this tiny little thing is 140 amp welder. So it's primarily a stick welder, but you can get a TIG welder for it. So let's run outside and jump on that old chassis and just have a bit of a go and see how this thing works.
So it's been a very, very long time since I've played with a stick welder, and yeah, it really shows. I was sort of scratching around and struggling and wasn't really using it to its best ability, but trust me, it works.
All right, I haven't done any stick welding in many, many years, and it really shows. They are some very, very horrible welds, but the benefit, or at least of a stick welder, is the ability that you can come outside and weld like this. So you don't get worried about the gas getting blown away and things like that. You can go and fix a fence post. They're great for farmers and things like that. You can actually sort of take them out and run them outside, which is really handy. And Weldclass, who are awesome, are actually giving away 5 of these welders this month. So get in there, use my link, and go into Weldclass and enter in the competition, because 5 of you are going to win one of these in the next month. They do have an attachment that's available for a TIG as well. So yeah, it's just a fantastic machine, and tiny, so small. Yeah, don't let this be an indication of what the welds can be like, because you can actually weld, as I said, up to like 140 amps with this, so you can actually do some really good welding. Just yeah, just not with this guy. Anyway, let's get back into the build.
So here you can see that I start out with a TIG welder, but it's a really awkward position, so I end up switching to the MIG, which is just better in this particular case. And it's really good to have TIG and MIG at my disposal, because they both have pros and cons, like I mentioned.
All right, well, that was a pretty ugly repair. It was very awkward to get in here. It was difficult angles and stuff, but that is fixed enough for the time being. The top of the roof, as I said, I'm going to have to make a new roof skin later. I don't have an English wheel at this stage. So let's go around and have a look inside and work out how we're going to replace all the structure in there now. All right, so I've got the inside relatively cleaned up now, and I've trimmed out these corners on either side, which I'm going to have to make a piece for. But before I do that, I want to seal it all in. So I'm going to use some of this stuff, POR 15, which has been highly recommended by lots of people. So let's get in there now and put a layer of that on this so that when I seal it in, it's all encapsulated. The rust is not going to go any further, and yeah, we should be good to keep repairing.
So I start by thoroughly cleaning everything like you always should before you paint anything, and just brushing on the POR 15. Quick tip for young players, maybe wear gloves, because this stuff sticks extremely well to your fingers, and it's been days and I've still got it all over my hands. So as you can see, the guillotine didn't like this thick 1.8mm steel, so I ended up cutting it off with the angle grinder. I tried bending it and tried using the shrinker stretcher, but it's just too thick, so I ended up cutting it into 2 pieces and did it as 2 separate sections rather than trying to shrink and stretch and make it the shape that I needed.
All right, so these repairs are looking quite nice. That one and the one over on that corner, they're nicely repaired and tied into what was there. So people often asking what thickness of material you use for your patches, and it depends on what I'm taking out. So generally, when I cut out a patch, I look at the thickness of the metal and replace it with like for like. Most external body panels on vehicles, pretty much everything I've ever worked on, is the thinner stuff, which is the sort of 0.9mm. This is 1.8mm steel, so that's actually what I used on this internal stuff in here. It didn't work on the shrinker stretcher, it's just too thick for that little shrinker stretcher, so I did it in a couple of pieces. But yeah, generally look at what you're cutting out and get something to match. I go to my local steel supply, and they generally have offcuts that are just sort of, you know, 800 by 900 or something like that, and you know, whatever they've got in whatever sizes, I just grab a couple of offcuts and bits and pieces so that I've got a bit of a stockpile of what I need. All right, moving on. All right, so the next thing I need to make is something I don't actually have any reference panel for because it was totally rusted out, and basically it's a shelf panel that sits all the way along the top edge here, and it actually joined this panel that you saw me work on before. Basically this panel clips on here, and there's a ledge that goes across and joins up here. So this needs to be sort of a relatively flat panel all the way along, but then it kicks up to where it was spot welded onto this edge. Now you can see I didn't repair all of this edge. I left it because I thought basically I'm going to be making this new edge. I'll make that up and just sort of weld it on as I see fit. So let's start templating out with cardboard and see what we come up with.
So first of all, I'm getting an idea of a rough measurement of how far I need that little shelf to come out. And then I start templating with my cardboard just to get a basic design and get the shape of the edge of the roof. Then I transfer it onto my 0.9mm steel sheet and start trimming it out. This throatless shear is a recent addition to the garage, and it really makes short work of this sort of trimming.
All right, so I marked my template in cardboard and then cut them out of sheet metal, and these 2 curved bits fit in here nicely and make that sort of shelf that's supposed to be in there, and it needs to come out and then tip up to join on with this plate in front. So to tip up this edge, I'm going to use the bead roller and see if I can sort of turn it up and get that shape that I want.
So these shelves started a bit oversized. Now I'm trimming them to the exact right size and then putting them through the bead roller to tip over the edge, just so I've got the right shape. And then it's a matter of a bit of hammer and dolly work to get them to sort of sit flat again and get them at just the right angle to meet up with the panel that I've already repaired.
All right, so I got my pieces out and tipped the edge nicely with the bead roller. I don't have the right tipping dies, but that worked quite nicely. Managed to get it all nice and straight again, just for hammer and dolly, and I've got my tipped edge. So now these need to be welded into place. I'm going to use the MIG. Let's do it.
So in this case, the welds are going to be hidden inside this panel, and it's just much easier with the MIG. So that's the weapon of choice for this particular repair.
All right, so the welds are pretty ugly. There was all sorts of contamination and stuff, but basically I've got my shelf now sitting in there quite nicely. This is all now a nice solid strip, rebuilt, and I can now start working on moving up this panel. I've already painted it all with some weld through primer, so let's start working at putting this all back together.
So when I started fitting this up, I could see that the panel I repaired just wasn't fitting properly, so I had to actually trim it in bits and actually cut one end off of it to get it to fit on. But as I worked my way around, I just kept manipulating it to get it to fit right, and using the MIG, tack it on, just make sure that everything sort of gets into the right places, and it actually ends up being quite a nice repair.
All right, and that is repaired, and that is actually probably the main bit of rust on this whole cab that was worrying me and was going to be difficult. And I have my channel in all the way around here now. It's back to the way the factory would have done it-ish. It's not the prettiest repair. Ultimately, it would have been better if I could actually replace it if there were parts available, but there just isn't. This being a 1954, the 1953 to 55 are all basically the same cab. The 1956 is a 1 year only, and there's all the parts for the 56, but there isn't for the 53 to 55. So they're just not available. It's repaired. It's going to do the job nicely. It'll hopefully live another 70 years. So I think that's all the time I've got this week. So I think that means it's time for Fun Facts with Mrs. Jeff.
Hey guys, after Henry Ford's first engine sprang to life on Christmas Eve 1893, he continued to experiment with engines. In January of 1896, he began work on a larger engine, working towards his first automobile. The motors, wheels, axles and steering tiller were all made of metal, but the rest was made of wood. It was nicknamed the quadricycle. This was because of its 4 bicycle wheels and its lightweight construction, and it was by far the lightest vehicle of its type to be produced at the time. The quadricycle had 2 speeds, 10 miles an hour or 20 miles an hour, selected by twin drive belts. It had a neutral gear, but no reverse and no brakes, but it was equipped, however, with a doorbell as a horn. Early on the morning of June the 4th, 1896, the quadricycle was ready for its maiden voyage, but Henry realised it was too wide for the garage door. So he did the logical thing, for him, and probably not for his wife. And he took an axe and he broke the framework and the bricks to be able to get the quadricycle out the door. Once the quadricycle was out in the daylight, he spun the flywheel and the quadricycle roared to life. So for the significant maiden voyage, he drove it slowly down the Detroit streets, had his friend riding ahead on a bicycle to clear the way, I guess, or warn people. Ford sold the quadricycle later that year for $200 to fund further vehicle projects, but he bought it back the following year for only $65. It still survives today, and it can be seen at the Henry Ford Museum in Dearborn, Michigan.
All right, I'm quite happy with the progress this week, getting all of this stuff done. It's not stuff you really see, but it was by far the most difficult part, I think, of the cab that I can see that to repair. A lot of the rest of it is going to be a little bit more straightforward, besides having to fabricate a new roof, but we'll deal with that when we get there.
It's the unglamorous side of car repair, isn't it?
It's the things that need to be done to be able to move forward, but I'm really getting through the rust repair on the cab. The rest of the body, there's not a lot to it. There's the doors, there's a little bit on the doors, but it's moving in the right direction, and hopefully soon we'll be able to start tackling the bus itself, which should be
super
fun.
Exciting. Great. Like, subscribe, let Jeff know what you think. He loves to read your comments.
Yep.
Got a golden retriever fur. Let me just remove that. Molting. And if you want to follow us on Patreon and help us out, that would be very much appreciated, and see the videos a day early with no ads. I think that's everything.
It. Yep. All right, guys.
Okay.
We'll see you next week.
Next time.
See you guys.
Bye. Hey guys, after Henry Forsce, in January of 1896, he began work. The motor, there's only one. The motor, wheels, axle. It was nicknamed the quadricycle. I'll do it again. It did, however, come equipped with a bell, a horn, honk honk.
No, there's a doorbell.
So with an axe, he did the logical thing and broke. His wife loved this. And it was by far the lightest vehicle of its type to be produced at the time.
Yes.